Alright, boys and girls, welcome back to the drive-through. Into the final section of Chapter 9. And this is where it starts getting weird and awesome, okay? So, now we're going to take the sum of geometric series. I guess I don't really even need the word sum, because geometric series is a sum of a geometric sequence. Now, what's a geometric sequence? Well, this is from earlier, so it might look like this. How about if our first term is 2, and then 6, and then 18 times 3 might be like 54, and then like 112. So, a geometric series, you multiply to get from one term to the next term. Okay, so I'm going to give you some equations here. And if you are in Accelerated, you're going to have to memorize these equations. Everyone else is going to be able to bring a note card to these tests and quizzes, okay? So, the sum of a geometric series with n terms is the first term, a sub 1, times 1 minus r to the n, where r is that rate of multiplication, n is how many terms we have, all divided by 1 minus r. So this is something that the Accelerated students are going to need to memorize, okay? Now, let's talk about an infinite geometric series with r greater than 1. So now these are series that never end. Okay, so like this one right here, we're talking about this right here. So what would be the sum of 2 plus 6 plus 18 plus 54 plus 112 plus 336 all the way until we got to term number infinity? Well, the answer would be humongous. How humongous? It would be infinity because it never ends. Okay, so no big surprise there. If you add up a lot of numbers an infinite amount of times, and if the numbers are growing, the answer will be infinity. That hopefully makes sense to you. But here's the wild one, okay? Let's consider this. Let's start with 10, and then 5. And then 5 halves, which is 2.5. Okay? So then divide that by 2. And you get 5 fourths, which is 1.25. Divide that by 2. And you get 5 eighths, which is 0.675. Divide that by 2. Then you get 5 16ths, which is, oh, I need to calculate. It's just 0.3125. Okay, and this goes on forever until you get to infinity. So these keep going. The amazing thing is that if you add up these things that go on to infinity, the answer is 20. That's right. That's the answer. The answer to the sum as n goes from 1 to infinity of 10 times 1/2 to the n power is 20. I swear. So how did I get that? No, I need to give you the equation, so I'm going to give it to you right here in this box. For a geometric infinite series with n less than 1 and greater than -1, the sum of all of the terms, all infinite amount of terms, is a sub 1 divided by 1 minus r. That simple. So how did we get 20? It was our first term, 10, divided by 1 minus, what was our r? Our r in this case was a half. How did we get from 10 to 5? We multiplied by a half. Then 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 we multiplied by a half. Our r is a half. So then you get 10 divided by 1 half, and that indeed is 20. So let's go. So this is a finite series. We have 10 terms. Okay? So we just got to go to our equation sheet. For a finite series, S sub n, the sum. Let's go back to our notes. It's A times 1 minus r to the n over 1 minus r. So it's A sub 1 times 1 minus r to the n all over 1 minus r. So in this case, A is 40. It's our first term. Okay? N is 10. And what is our r? It looks like our r is, again, 1 half. The first term was 40. The second term was 20. The third term was 10. R is a half. So the answer for the sum is 40 times 1 minus 1 half to the 10th power all over 1 minus 1 half. Well, what's 1 half to the 10th power? Let me do this whole thing in my calculator. It's 1 minus 0.5 to the 10th power. So it's 40 times 0.9999023. Is that right? All divided by a half. I don't love this. You get 79.92. 1875. All right, I'll buy it. Maybe I'm wrong. We'll see. I think that's right. I think I did the stuff right in my calculator. Let's do number 2. Okay, this one, since it's getting bigger, it has to be a whole number. It has to be. So, S sub n. I write this, and as I write it more often, I'm more likely to remember it. 1 minus r to the n over 1 minus r. N is 15. A is 4. And r, it looks like, is 3. 4 times 3 is 12, times 3 is 36. So it's equal to 4 times 1 minus 3 to the 15th power all over 1 minus 3. Alright, so what is 1 minus 3 to the 15th power? So it's 4 times negative 1, 4, 3, 4. You should just leave this in your calculator. I'm just writing it down so you can check your steps as you go. All over negative 2. So let's see, multiply that times 4. Divide by negative 2. And the answer to this question, I can't even put bam, bam. And that's the sum. Okay, so what do these words diverge and converge means? Okay? So the diverge means it goes to infinity, and converge means it goes to a number. So all we have to do is check our R. Here it looks like R is a half. We multiplied by a half. We multiplied by a half. So since R is a half, when we add all these things up, it's going to converge to a number. Okay? Here, what is our R? It's a half again. So it's going to converge. Okay, but here, oh, again, R is something that's less, I don't even know what it is, I don't even need to calculate it. I know it's less than 1, because each term is getting smaller. So I know that this converges. Keep doing the homework and find a couple that diverge. Alright, finally. Whoops. Okay, so here we have an infinite amount of terms, and we want to find the geometric series, the sum of this sequence. Notice that R is a half. That seems to be a common theme. A sub 1 is 8. So the sum is, well, it's A sub 1 over 1 minus R. So it's 8 divided by 1 minus a half. 8 divided by a half. The answer to all of those terms. If you add up all of them, you get 16. Enjoy the rest of it. Boom!